Hello and welcome to today's video. My name is Ashutosh Karve and we are going to dive into embedded C questions and the core logic behind them. If you are gearing up for an embedded software role or you simply want to sharpen your embedded C skill, you are in the right place. In this session, I will walk through some questions like what is embedded C, common topic for interviewers loves to ask about, some detailed example of problem solving technique, practical coding exam exercise, and tip to ace your next interview. By the end of this video you will have clear understanding of how to tackle a typical C questions in confidence methodological way. So let's get started. So first of all, we'll start with what is embedded C. Before we jump into the specific interview question, let's clarify what embedded C really means. Embedded C is not just a regular C. It is an extension of this C with a feature of constraint tailored from microcontroller and embedded system. Typically, embedded platform have limited memory, strict timing requirement, and access to the specific hardware register. Unlike standard C program running on an operating system, embedded C often run directly on a bare metal of microcontroller, which means we engineers have great responsibility for managing memory, timing, and hardware interactions. In interview, you will hear a question about a register manipulation, interrupts, timing, and bitwise. I will note it down here some things like register register manipulation, interrupts, timing, and bitwise operation. Among other, understanding this fundamental is crucial for showcasing expertise in embedded C. So let's start with common interview topic. So now let's move on to the main interview topic you would like to encounter. First of all, data types and memory. So interviewer will often ask you about fixed bit integer such as unt8t, unt16t, and unt32t. They want to see if you understand how each type affect memory usage and performance. Second one is bit manipulation. Bitwise operation like AND or XOR and shift are the heart of the embedded programming. AND or XOR and shifts. So you will frequently need to set clear and toggle a specific bit in a register. So knowing this operator inside and out is an essential. Third one will be interrupt. So interrupts are crucial for real-time responsiveness. Employer expect you to know how to configure and handle. So as well as how to share variables between interrupt service routine ISR and main application. And also whatever the code you write, or apart from this, interview will ask about optimization technique. So embedded devices often have limited resources. You must be able to discuss strategies for optimizing code size, execution speed, such as using inline functions, minimizing recursion, and carefully managing memory allocation. So I will give you some example of bit manipulation. Imagine you have 16-bit register called REG. You need to set bit 5 and clear bit 3 and toggle bit 7. How do you do that? Let's think about it. Setting bit involve ORing the register with mask that has 1 in its bit position. So how we will do that? See, in register we will do ORing. We will do ORing like set bit 5. Okay, so for clearing bit involve ANDing the register with inverse of bit masks, like a register will AND and then inverse with bit mask, so it will clear bit 3. Yeah, and toggling, where we will XOR, involve XORing the register with bit mask, so we'll XOR with bit mask, so it will toggle bit 7. So these 3 lines of the code quickly demonstrate your understanding of bitwise operation. It also a great chance to show you that you are comfortable with binary shift, mask and concept of the bit numbering. Another important interview question is that they will ask about volatile keyword. So question will be like, what is the purpose of the volatile keyword in embedded C? In what scenario is it commonly used? So answer will be for this is the volatile keyword tells the compiler that a variable can change in a way that compiler cannot predict. So it shouldn't optimize or read out write the variable. This is crucial for embedded system because hardware register, the value of the hardware register might change on its own due to the external event. Global file flags modified by interrupt. If ISR set a global flag, the main code must read it exactly as it is without any compiler optimization. This might skip rechecking the variable. So memory share between the task. In RTOS or multi-threading environment, multiple tasks might read and write to the same variable. In an interview, it will be helpful to explain a real life world example, like a hardware status register that changes when external sensor is triggered. If you forgot a volatile, the compiler might assume that variable never changed, leading to an incorrect behavior. This is the basic example you can explain to the interviewer. Second thing they will ask about interrupt service routine, ISR. So the basic question will ask, how do you write an interrupt service routing ISR in C, and what are the key consideration? And ISR is a special function that runs automatically when a specific interrupt occur. Depend on the compiler, you may have special keywords or pragmas. For example, I will show you pragma vector. Here we will write ISR logic. So what will be the key consideration? Keep it short and efficient, because ISR was the main program flow. They should handle only time critical task and exit quickly. Use volatile for shared variable, and variable accessed by the both the ISR and the main code should be declared as a volatile. Re Safety will be mindful for global variable that could be accessed by multiple ISR or the main program, like reentrancy and safety. Synchronization of disable interrupt temporarily might be required. Showing your knowledge of the best practice indicate the interview that you understand real-time constraint are reliable in embedded system. So some other question they will ask about memory mapped IO. Question, you explain memory mapped IO and how you can access hardware register directly in embedded C. This can be the question, like explain the memory map IO and how you could access hardware register directly in embedded C. The memory map IO means the certain memory addresses on your microcontroller map directly to the specific register. You can define pointer to this address to read or write those register. For instance, for example, you can write to show the example, you can write hash define GPIO port. Okay, volatile unsigned int, and this will be the declaration number. So when you write GPIO port is equal to 0x01, you are effectively writing the hardware register at this address. Again, note the use of volatile to prevent the unwanted compiler optimization. The ability to correct, configure, and interact with the memory map register in fundamental is embedded development. So expect this to be the hot topic in interviews. And this is the common question they might ask about volatile and interrupt service routine and their relations. So some of the practical coding exercises they will take. Suppose the scenario, they will give you some scenario. You have an LED connected to the microcontroller pin and you want to toggle it every 500 millisecond using a timer interrupt. How you write that code in embedded C? So give them a possible outline, like define the LED pin and the address port, then initialize the timer, so trigger an interrupt every 500 millisecond, and write ISR that toggle LED pin, enter the main loop, and MCU do the task. So this is the flow. First you will define LED pin, okay, initialize the timer, write as an ISR, this will toggle the LED pin and this will trigger after 500 millisecond, and then enter the main loop. And let's do other task or simply idle. First of all, let's write some code regarding this. Suppose they say to write you the code, then define some LED, define LED pin I is less than equal to 0, okay. Then this LED pin is connected to bit 0. Define the port with the hypothetical port address, then create a timer function, and then toggle the LED with a external interrupt pragma you can use, and then include in the main. You can show that basic outline which I have given here as a code. I will share in the chat box if you need. So basic tip for interview successes. Before we wrap up, let me share some valuable tips to help you succeed in your embedded C interviews. So think loud. Interview want see you approach, not just a final answer. Explain through process step by step. Stay hardware specific. If you know the microcontroller family like AVR, ARM Cortex, PIC, mention relevant register or datasheets. Demonstrate practical knowledge. Focus on real-time constraint. Explain system often have strict timing requirement. Show you understand the real-time means can address potential latencies. Code clarity, you can do write readable and well-structured code. Use comments, avoid unnecessary complexities, and demonstrate content name conventions. So these are some of the tips which I will give you, and also discuss about your practical implementation of the code in your recent project or in past project which you have overcome or tackle while doing it, the new logic which you have implemented, or the problem you have faced and how you have solved it by yourself, how you approach that with the step by step. And that brings us to the end of this today's session and embedded C of the interview question. I hope a walkthrough has given you a clear picture and typical question you can expect how to handle them logically and confidently. If you found this video helpful, please consider subscribing, share, or leave a comment box. Thank you so much for joining me. Good luck for your upcoming interviews, and I will see you in next video. Until then, keep coding, keep experimenting, never stop learning.